Hello, my name is Anthony Martin, and this is the recording of the Advanced Data Science Capstone project, um, in which I will be doing a stakeholder presentation for the use cases and best practices and overall overview of the deep learning network that I've created for the Capstone project. So, without any further delay, get into it. Let's see. Okay. So I have now the presentation up. Apologies, I don't know uh, how to share both the presentation as well as myself, but that's okay. So we do have uh, so the beginning of the presentation is the IDC identifier, is the name of the project. IDC stands for invasive ductal carcinoma. It's the most common type of breast cancer found in women. And then breast cancer being the most common cancer type overall. So use cases for the project is we want to get results faster for the sake of researchers and patients. Right? Identifying these cells needs to be both swift and accurate. So we utilized a set of uh, extracted images taken from whole mount slides, um, cut those down into 50 by 50 chunks, 50 pixels by 50 pixels, and we're going to analyze them using a deep learning network. The goal of the project is to assist in analysis and researchers in the identification of uh, how rapidly these things are growing and the parsing the exact location of these IDC cells. The successful deployment of the process is we want to increase the speed at which researchers can work through both uh, analysis time and response time back to the patient. Right, the process uh, is successful by speed. Success of the project is defined by that speed, right? Recaptured time is the measure of our success. So, why a deep learning network as opposed to another? A deep learning network allows us to continually iterate over with larger and larger data sets and get more and more accurate results as the computer learns. Deep learning networks are great for unstructured data. As we're working with pictures, this is equally paramount. Right, the amount of unstructured data that we want to use and keep using is makes deep learning an excellent choice. So we want to continue optimizing and having the amount of information inform the network rather than bogging it down. So in this case, we want researchers to be able to put pictures in, get labels out, and have it be simple as that. So up next is the data set acquisition and assessment. We found the data set on Kaggle.com, a popular data science and learning website. The repository can be accessed through Kaggle.com. The full citation is in the appendix. And the notebook was also open via Kaggle. Because it was a Kaggle hosted data set, we found it best to use a Kaggle open web notebook, and plans for the future is to reroute that Kaggle directory to a local or cloud-based directory for use with enterprise data, as opposed to Kaggle's own public data sets. So, insofar as data exploration, we within the notebook we were able to view a set of images and their associated labels to make sure that they are actually images and they are labeled. Um, Unfortunately, I'm not a microbiologist and or cancer researcher, so I cannot verify the uh, the cell data and what it means, but I'm trusting that the researchers who manually input all this information know what they're talking about. The data set itself has been tested and approved to be enough to earn a gold citation on Kaggle's website. So I believe that it is an accurate data set. So when enterprise data starts rolling in, uh, that will be the first measure of training, and then subsets for testing, and then we can grow the data set using enterprise data when it becomes available. The pictures, right, as they are now, were then transformed into four-dimensional tensor objects, and then those tensor objects were then read by the deep learning model. So the deep learning model was run both before and after normalization, using the same training data. You can see graphs of each of these by the off on the screen's left. Though both models achieved 95+% accuracy rating, the normalized model was able to do so much more efficiently, and with a smoother running time. The normalized version was able to run 10 milliseconds faster per epoch, and will run more efficiently with larger data sets than the unnormalized version. For a measure of accuracy, we used a confusion matrix to check the difference between a predicted set of labels and the true labels that were with the set of data. So in this case, we only had a 3% misidentification rating on our sample test set. The confusion matrix was run for both the deep learning model as well as a comparative logistic regression model. The logistic regression model was built and tested using the same image set as the initial deep learning model, and the logistic regression model was not able to successfully classify any of the IDC cells that it was presented with. Further justification for the use of a deep learning model over a logistic regression model in this case. The conclusions, the accuracy of the model allows for more time, right? Faster identification using a deep learning network means more time for researchers, more time for patients. That's the optimal ideal, right? For further plans, for growth, we're going to use the coordinate system that's built into the file names to build a list of areas where IDC cells are present, right? Using the identification feature within the deep learning network to create a list of where the cells are present and help measure their aggressiveness and guide treatment areas. So, thank you very much for listening. Up next is the appendix, which has all of the citations. Um, yeah, here, look, there's an appendix for uh, that contains all of this. And so now, stop sharing. Back to my back to me. Uh, so thank you very much for watching. Uh, I hope you enjoyed it. I certainly had a whole lot of stuff to learn with the development of this model. Um, it taught me it taught me a ton insofar as comparative models, normalization, how to get stuff, where to get stuff, choosing the best model uh, for the project at hand, as well as teaching me a bit more about cancer research and how and what to pursue within those guidelines. So, thank you again for watching, and have a lovely day. Is the name of the project. IDC stands for invasive ductal carcinoma, which is the most type of common. It's the most common type of breast cancer found in women.